Welcome back. In this video, we'll discuss section 21.5, errors. When we perform a hypothesis test, we can make mistakes in two ways. The first way is this. The null hypothesis is true, but we mistakenly reject it. We call this a type 1 error. The other way we can make an error is this. The null hypothesis is false, but we fail to reject it. We call this a type 2 error. This information is summarized in the following table. The columns contain the truth. The rows contain our decision. So for example, in this first column, H naught is true. And then if you look at row 1, that's our decision to reject H naught. Well, if H naught is true, we should not be rejecting it. This is a type 1 error. If H naught is true and we fail to reject H naught, we've done the right thing, and so this is okay. In the second column, H naught is false. If we reject H naught, we've done the right thing, this is okay. But if we fail to reject H naught, we've made a type 2 error. One of the main ideas we'll discuss in this video is that of the power of a test. This is the probability that it correctly rejects a false null hypothesis. In other words, this is the likelihood of avoiding a type 2 error. Remember, with a type 2 error, the null hypothesis is false, but we fail to reject it. We'd like to address the question, how often will a type 1 error occur? If you look at this diagram, it's for a hypothesis test for a proportion. We could also draw a diagram for a hypothesis test for a mean. The null hypothesis is that P is equal to P naught. The alternative hypothesis is that P is greater than P naught. So if you look at the top curve, we're supposing the null hypothesis is true, and we've set this arbitrary threshold alpha for our p-value. Alpha is the area of the tail, that region in red. If our p-value is less than alpha, we'll reject the null hypothesis. Now, when the null hypothesis is true, this happens exactly with probability alpha. So when we choose our alpha level, we're setting the probability of a type 1 error to alpha. We'll assign the letter beta to the probability of a type 2 error, and we'd like to know what is the value of beta. This is a little bit harder to decide than alpha, the probability of a type 1 error, because we don't know the true parameter value. So if you look at this bottom curve, suppose the null hypothesis is not true. That means P, the parameter value, is greater than P naught. But it doesn't tell us what P is. For larger values of P, we'd have to shift this bottom curve to the right. That gap between P and P naught would get bigger. We'll still have some samples with a sample proportion less than this critical value P star, which is right here, which means we would fail to reject the false null hypothesis, and we'd commit a type 2 error. So the area of this region here in red is beta. Because the total area under the curve is 1, the area of this region over here in blue is 1 minus beta, and that's the power of the test. Remember, that's the probability of correctly rejecting a false null hypothesis. So it's the likelihood of avoiding a type 2 error.